Hello, everyone. I hope we are doing well. Today, we'll be covering our topic on the integumentary system, and I welcome you to the session. Here are our objectives or the scopes of the session. Today, we'll be covering the development of the skin, the outer covering of the body, so the skin. We'll also look at the development of the appendages of the skin. So we'll talk about the hair, the fingernails, the sweat glands, and even modified sweat glands, which are the mammary glands. And then we wrap it up by looking at the various anomalies, the congenital anomalies of the integumentary system that affect the skin, the fingernails, the sweat glands, the mammary glands, and all the appendages in summary. So we'll just start by looking at the normal anatomy, the normal gross anatomy of the skin. So the skin has three layers. We talk about the epidermis, dermis, and the hypodermis. So the epidermis is the outermost layer. Of course, the five layers that form the epidermis, starting from stratum basale to stratum corneum, forming the five layers. Of course, we can appreciate a layer of keratinization that is present, so forming the stratified squamous, and keratinized epithelium that is forming the epidermis. And you also have the dermis now. The dermis at this point, it has the dermal papillae, and then the reticular dermis that is present here. And the hypodermis is a layer of subcutaneous tissue that contains deposited fats. And also it contains blood vessels and nerves and other structures. These are cross-section, a deeper cross-section showing us the skin together with its appendages. At this point, you can appreciate the epidermis with the layers, stratum corneum, lucidum, and other layers have been pointed there. Then at this point, for the dermis, you can appreciate it has various receptors and even the pilosebaceous unit. You can appreciate the presence of a rectal pili muscle. They have follicle and sebaceous gland that forms the pilosebaceous unit. So this is a rectal pili muscle. This is a sebaceous gland, the presence of the hair follicle. Also, you can appreciate that these dermis will have some receptors, some of them being Pacinian corpuscle. We'll also have Krausenberg, or called Ruffini endings for heat. We'll have some blood vessels there. We'll have Meissner's corpuscles for fine touch. We'll have double papillae concept there. And they also have even the macular discs, the sweat glands, or which we see the various types of sweat glands. So those cells will be found in the dermis. The hypodermis will also contain some blood vessels and also will contain deposited adipose tissue, as you can see there. But before then, we need to have a brief overview of what the skin is. The skin is the largest organ in the body. Skin is the largest organ in the body, covering the whole body. Given the fact that the skin is an organ, it has blood supply, it has lymphatic drainage, and then it has innervation. So what are the functions of the skin? The functions of the skin are many, but here is a brief overview of some of the functions of the skin, starting with protection, temperature regulation, excretion, of course, immune system, given that it has antigen-presenting cells, some of them being the Langerhans cells that are found in the skin, and other structures. So let's go now to the embryological bit of the skin now. So the skin embryologically comes from two origins. One of them is surface ectoderm, that is the dermis, that is epidermis. Then the mesenchyme give us the dermis. So the mesenchyme is mesoderm from various locations. So surface ectoderm give us the epidermis, mesenchyme give us the dermis. Of course, now the dermis now, the hypodermis will come, of course, now from the mesenchyme. So we start off by looking at the epidermis, and we say that its origin is a surface ectoderm. So at this point, you can appreciate how the ectoderm, surface ectoderm, then you have the mesenchyme. Remember, this mesenchyme is coming from three locations, and we talk about this mesenchyme of the dermis will come from three locations. So, but at this point, I'm focusing on the ectoderm, which gives us the epidermis. So two things will happen. The ectoderm will divide into the second month. It will divide into two, the periderm which is also known as the epitracheum and the basal layer. So that is well shown in this. So the basal layer remains here, and then the periderm is actually the outermost layer of flat cells. I appreciate this layer of flat cells. So another thing happens, this basal layer will act like the stem cells. They will contain this mitosis. They will contain this cell division property that will continue to have. And through that now, it will divide. The basal layer will continue to divide to give us a third layer, which is known as the intermediate layer. So the intermediate layer will come across during the third month. This is the intermediate layer, we can appreciate it there. So the basal layer, the intermediate layer, and then there's a periderm. So at around now the third month, you have three layers. Basal layer, intermediate layer, and the periderm. So at the end of the fourth month, you have now the intermediate layer, giving us four definitive layers of the epidermis being formed. So we talk about stratum, basale, stratum, spinosum, stratum glandulosum, stratum lucidum, and then stratum corneum. Stratum lucidum, remember, it is found only in the thick skin. Then now the remaining four layers will be found in the thin skin, of course. So that is majorly about it. We can appreciate now, at this point, you have the five layers. You can appreciate the germinative layer or the basal layer. You can appreciate the spinous layer or the stratum spinosum. Is a granular layer, stratum granulosum. Then you can appreciate the horny layer or the stratum corneum. So the basal layer, the germinative layer, ideally produces new cells. It has furrows and ridges, and then it has that mitotic activities. They are highly proliferative, easily divided. Then you have the spinous layer. The spinous layer is the layer just after the germinative layer. So these cells has polyhedral in shape, and then they contain fine fibrils. For the granular layer, given the fact that they're called granular layer, they give us the granulosum layer. So has small keratohyalin granules. And then the last layer, stratum cornea, at this point is a horny layer with scale-like cells containing keratin, and then the cells actually will have flattened nuclei. A point of appreciate is that we'll have a fifth layer in the thick skin, which is between cornea, stratum corneum, and stratum granulosum, the layer known as stratum lucidum, which is the translucent layer, one that is found between granulosum layer and corneum layer. And that stratum lucidum acts like a boundary between the two layers. Other cells will come across, will appreciate the presence of melanocytes there. You can appreciate presence of melanocytes here. So melanocytes and other cells that we saw, the Merkel cells, will be coming from neurocrine cells. So remember, the neurocrine cells are the ones that formed during the process of neurulation. So neurocrine cells, they are a replica of the nervous system in other regions. So melanocytes and Merkel cells come from neurocrine cells. Then another important thing happens. So the periderm sloughs off. The periderm sloughs off during this development and forms a whitish paste that we'll see in a few minutes. What's the function of this whitish paste? That is known as vernix caseosa. Then you talk about the dermis. So the dermis comes from mesenchyme. Remember, we talk about the dermis coming from the mesenchyme, but now this mesenchyme will be coming from three locations. The three locations are the lateral plate mesoderm, the paraxial mesoderm, and the neurocrine cells. So the lateral plate mesoderm will form the dermis of the limbs and the body wall. So upper limb, lower limb, body wall means the trunk, except the back. And then for the paraxial mesoderm, it will give us the dermis of the back. And then the neurocrine cells will give the dermis of head and neck. So remember, the neurocrine cells, they will form the brachial apparatus, the brachial apparatus of head and neck. And then the brachial apparatus are the structure that form, are the apparatus that forms, are the structure that form the organs of head and neck region. So already you have the mesenchyme coming from all the three locations. So at the end of the fourth month, what happens is that the dermis, which is also known as the corium, will form irregular projections. Will form irregular projections into the dermis, forming the dermal papillae. And then this dermal papillae will be containing capillaries, mucinous corpuscles, and other structures such as lymphatics. So remember now, capillaries, mucinous corpuscles will be formed by the mesenchyme that is just next, that is inside that dermal papillae. So capillaries by angiogenesis. Mucinous corpuscles are receptors, and then of course lymphatics will be formed by formation of lymphatics. Then the region that is just below the dermis, remember the dermis at this point is being called the corium. The region that is just below it will become the subcorium. What will happen to the subcorium is that it will be deposited with fatty tissue. It will be deposited with fats, forming the adipose tissue. That's the reason it's called subcutaneous tissue. It forms the hypodermis. So at this point, you've already formed the three layers. You formed the epidermis, you formed the dermis, and then you form the hypodermis. Then I hope you can remember the periderm that we talked about, the outermost layer. So the periderm which degenerates, which sloughs off, forms the vernix gaseosa together with degenerated epidermal cells, sebaceous glands, epidermal cells, and hair. So those structures. So this is a vernix gaseosa is a whitish paste covering the skin from secretions of sebaceous glands, degenerated epidermal cells, and hair. So at this point, this vernix gaseosa protects the skin during birth and even before birth against the macerating action of the amniotic fluid. So it has a protective function, just preventing the macerating action or the ulcerations that will come into the amniotic fluid. So this vernix gaseosa will occur as a whitish paste during birth. Then after, of course, due to washing of the baby, now the vernix gaseosa it ideally comes off. So we'll go ahead and then discuss the various appendages of the skin. The first one we'll talk about is the hair. So the hair develops as epidermal proliferation or epidermal penetration. So through epidermal proliferation, you'll have penetration of this hair bud into the dermis. So you have the epidermis develops a bud going downwards. The bud undergoes proliferation and then it penetrates the dermis. So an interesting thing happens here. So we've seen that this solid epidermal proliferation of the germinating hair, then it penetrates the underlying dermis. Then another interesting thing will happen, it will have invagination. Invagination of the terminal end of the hair to give us the hair papillae. And then this hair papillae, it has mesenchyme below it. What will happen to the mesenchyme below it is that the mesenchyme will differentiate to form blood vessels and nerves and even lymphatics at that point. So the invaginations are filled with medulla, which vessels and nerves are formed. Then the hair shaft. The hair shaft will be formed by keratinization. So the cells at the center of this hair bud will undergo keratinization, while the cells of the periphery will become cuboidal in nature and form epithelial hair sheets. At this point, we've already formed the hair, which penetrates downwards into the dermis, but is coming from the epidermis. Then you can appreciate that now you have a smooth muscle here, the ectodermal muscle, and then you have a sebaceous gland. Then the dermal sheets. So you have epithelial sheets, and then you'll have the dermal sheets. So the dermal sheets, so these in blue is the epithelial hair sheets coming from the dermis. Then you have the dermal sheets, which are now coming from the dermis, the surrounding mesenchyme. So parts of our hair shaft is that we have inner part which is keratinized, epithelial hair sheet which comes from epidermis, and then you have a dermal root sheet that comes from the dermis and mesenchyme surrounding it. We'll have an interesting muscle known as the right upper muscle, which is a smooth muscle. It will contain the characteristic of a smooth muscle. To talk about spindle-shaped cells, it won't be striated, it will require, it is involuntary in nature. So the erector pili muscle is formed from mesenchyme adjacent to the dermal root sheath. The dermal root sheath, which ideally the dermal root sheath talk about, coming from the mesenchyme. So also the erector pili muscle coming from the mesenchyme that is just next to the dermal root sheath. So the other gland I'll talk about is the sebaceous gland. So sebaceous gland together with the erector pili muscle together with the hair will form the pilosebaceous unit. So let's form the sebaceous gland, then we talk about the structure of the sebaceous gland. So the sebaceous gland is epithelial wall cells that fall buds that penetrate horizontally and penetrate the surrounding mesoderm. So epithelial wall of the hair develops small buds that penetrate surrounding mesoderm. And then these cells from the central portion of the bud degenerate forming a fat-like substance, which is known as a sebum. So those cells are known as the sebocytes, will degenerate forming a fat-like substance, which is a sebum. And then this sebum is now that is secreted into the hair follicles. And then after that, now into the skin. Remember, the secretions of the sebaceous gland, first of all, go to the hair follicles, then from the hair follicles to the skin surface. And as a better illustration of the same, you can appreciate is a hair shaft. So we have now a horizontal penetration of the mesenchyme by these small buds. Then the small buds will develop into sebaceous gland, and then from which now the sebocytes will degenerate, forming fat-like substances, of which now the sebum will be secreted into the hair shaft and then the skin surface. Just to wrap it up, you know the functions of sebum, which is antiseptic functions and then prevent the skin from drying, but not to finalize that. We have this primitive hair, the lanugo hair, which is the first hair to be shed off at birth and is replaced by coarser hair. So that is lanugo hair. So we talk about development of the fingernails, but before then we need to describe the normal anatomy of the fingernails. So at this point you can appreciate this is a nail plate, this is a nail fold, this is a nail fold. Then here we have the eponychium, this is eponychium. Then we have the lunula, the moon-shaped structure here, the whitish thing is the lunula. Then you have the germinal matrix. Then you have the nail bed. So the nail bed lies below the nail plate. And then you have the hyponychium, the skin that is just after the nail bed is the hyponychium. So the germinal matrix will give rise to the nail plate at this point. Then the nail fold is the skin, the hyponychium is the skin, and the hyponychium is also skin. Then the nail bed is found below the nail plate. The lunula is a moon-shaped part, the crescent shape that is found on the whitish part of the nail of the fingernail or the toenails. So between the third month, we'll have thickenings of the epidermis of the tips of the digits. So we have tips of the digits, which have palmar aspect and dorsal aspect. So on the tips of these 2 points, you'll have formation of nail fields. Then these nail fields will migrate towards the dorsal part of the digit to form the nail root. So nail fields migrate on the dorsal side and grow proximally to form the nail roots. Then these nail roots will undergo the tissue surrounding the nail fields will proliferate. So this nail fold, eponychium and hyponychium will be formed due to proliferation of the skin of the cells surrounding it, the tissue surrounding the nail plate, forming a shallow depression of each nail. Then now from the nail roots, the epidermis differentiates into fingernails and then to toenails and toenails until the end line. How does this nail roots differentiate? They differentiate by undergoing keratinization. So the nail plate will undergo keratinization to give us the definitive fingernails. We'll go to the sweat glands. Remember, you have 2 types of sweat glands. You have the eccrine sweat glands, you have the apocrine sweat glands. The eccrine sweat glands will be found in most body parts. The apocrine sweat glands will be found in the face, axilla, and the pubic region. A good example is this. So these are the eccrine sweat glands. It drains their secretions directly into the skin. The apocrine sweat glands, just as the sebaceous gland, will take their secretions directly into the hair follicle, then from the hair follicle to the skin. So actually at this point, you can appreciate the erector pili muscle, which is a hair shaft, appreciate the sebaceous gland, appreciate the apocrine sweat gland. So how does the apocrine sweat gland develop? Just similarly as sebaceous gland. How does eccrine sweat gland develops? Just develop the same way. The hair develops downward, like you have downward penetration of epidermal bud into the dermis, then you have penetration, canalization, then coiling of the secretory part. So eccrine sweat glands will be found in most body parts. Apocrine will be found in the face, axilla, and the pubic region. Then the sweat glands form from parts of the germinative layer of the epidermis, grow into the dermis, and then the rest of the glands will undergo coiling from the secretory portion. Then the smooth muscle of the glands come from the epidermal buds. So these sweat glands, eccrine sweat glands, will develop in similar way you'll have here. The apocrine sweat glands will develop during puberty. Then they develop the same epidermal buds that produce the hair follicle. So that is it. Then we'll finalize with the last mammary gland of the session, which is the mammary gland, the last appendage of the skin, which is the mammary gland. So just in summary, this is just a simple summary of how the mammary gland develops. First of all, you'll have epidermal proliferation, two bilateral epidermal proliferation appearing from the region of the axilla up to the groin region, two bilateral thickenings. So you can appreciate there are two bilateral thickenings. So what happens is that the two bilateral thickenings will degenerate apart from the thoracic region. Then these thickenings will proliferate and penetrate downwards towards the mesenchyme. And then this proliferation will give us mammary buds. The mammary buds will become 15 to 20 of them. And after that, this mesenchymal proliferation, the mammary buds will canalize to form the lactiferous ducts. Then, of course, we'll have the mesenchyme below it proliferating, enabling us this epithelial pit become inverted and not inverted. This will be appreciated, it's inverted. So due to the mesenchymal proliferation, it will become inverted. When it becomes inverted, now it will become inverted nipple. And after that, now due to the action of estrogen and progesterone, we'll have accumulation of fatty acids, or accumulation of fats and adipose tissue. So at this point, the mammary gland will become bigger and bigger in size. And then after that, now, of course, we know the various standard stages of the development of the mammary gland. So if you don't know, kindly go through the various 5 standard stages of the development of the mammary gland. But before then, here's a good summary of how the mammary glands develops. They will develop from the ectoderm, surface ectoderm, just the same way the sweat glands are coming from the ectoderm. So they are modified sweat glands coming from the ectoderm that appears bilateral band-like thickenings, as you appreciated in the last slide. Then this band-like thickening of epidermis are known as the mammary lines or the mammary ridges. These mammary lines or the mammary ridges, in the 7th week, they extend from the axilla to the hind limb or the groin region. Then most of it will degenerate except the region in the thorax. So this region in the thorax now, that mammary line or the mammary ridge will penetrate downwards, forming 15 to 20 mammary buds. So this proliferation, these epithelial band-like thickenings will proliferate and penetrate downwards into the underlying mesenchyme to form 15 to 20 mammary buds. These mammary buds will undergo canalization to form lactiferous ducts, and this lactiferous duct will open on where they came from. They will open in the epithelial pit, the epidermis. Then, after that, the pits become everted into the nipple by mesenchymal proliferation. So remember, these mammary buds, these lactiferous ducts are below, they penetrate into the mesenchyme. Then when the mesenchyme now proliferates, the nipple becomes everted. And now at puberty, now under the influence of hormones such as estrogen and progesterone, you'll have stimulation of these lactiferous ducts to form alveoli in the secretory cells. And now, of course, to finalize, we'll have deposition of fat, adipose tissue, then you'll have the various 5 standard stages coming across. So the standard stages starts from embryology, intrauterine life, and then you finish up to after menopause. So those are the standard stages. So kindly make sure you go through the standard stages of the development of the mammary glands. We talk about the various congenital anomalies of the skin. One of them is hypertrichosis. Hypertrichosis is a congenital excessive growth of hair. Atrichia is absence of now the hair. And at this point, the atrichia will be talking about even the eyelashes will be missing. Then polythelia, poly means many, then thelia means nipple, so multiple nipples. Poly means many, then mastia means mammary glands, so multiple mammary glands. This point we'll have inverted nipple. Inverted nipple is opposite of what? Like that means we didn't have proliferation of the mesenchyme. That's now we have inverted nipple. Then amastia. So amastia means absence of the mammary gland. Athelia means absence of the nipples. Then vitiligo is absence of melanin. But now at this point, when talking about vitiligo, it's patches of their skin is lacking melanin. Then ichthyosis vulgaris. Ichthyosis vulgaris is hyperkeratinization. So when now it happens embryologically and it's excessive a lot, it gives us the harlequin fetus, which is ideally compatible with life somehow. Then alopecia is actually absence of hair in the skull. So alopecia can be two: alopecia totalis, complete absence of hair, and then you can have alopecia partially. So alopecia totalis, complete absence. It can be congenital and also can be acquired. That is maybe by drug induced or something like that. In partialis, now we have patchy absence of hair in the scalp. Then we have congenital anonychia. So remember, we formed the development of the nails. So absence of the nails will give us congenital anonychia. Then you have gynecomastia or the narcomastia, that is absence of or presence of enlarged mammary glands in males. And albinism now is complete absence of melanin now. Then cavernous hemangioma is proliferation of capillaries on the skin. So it can be on the face, can be anywhere else, but it's ideally on the skin, cavernous hemangioma. We'll cover the various anomalies. Can appreciate we have normal nipples there, but now we have accessory nipples. So this one is polythelia. So presence of multiple nipples. This is albinism. Can appreciate this albinism. This is ichthyosis vulgaris giving us, but now at this point, ichthyosis vulgaris is hyperkeratinization. So these harlequin fetus. Harlequin fetus are ideally coming from hyperkeratinization, the ichthyosis vulgaris. Then this is vitiligo. They can appreciate the patchy absence of melanin. Then can appreciate at this point, now this is congenital atrichia. So absence of the patches. Yeah. Then you can appreciate this excessive growth of hair. So this is hypertrichosis. This is can appreciate presence of multiple nipples. So this is polythelia. Can appreciate this is presence of gynecomastia, presence of enlarged breast in the male. This gynecomastia or narcomastia. Then you can appreciate partial absence of hair. So this alopecia partialis. It is called alopecia partialis. And this other slide, you can appreciate the first image showing us hyperkeratinization. This is ichthyosis vulgaris. In this one, you can appreciate you have two normal breasts, then you have accessory breasts in the axilla. This is polymastia. And in this one, you can appreciate trend of proliferation. It is evident proliferation of capillaries on the skin. This beautiful chart, which is cavernous hemangioma. In this other slide, you can appreciate These digits have names, but this one doesn't have a name. So congenital anomalies. Then in this lady, there is absence of mammary gland. So this bilateral amastia, but not unilateral amastia. Then you have an inverted nipple. It's an inverted nipple, but this one can be corrected surgically. And it's going, you can appreciate these two beautiful twins. They have undergone hyperkeratinization. They each theosis vulgaris. Then this one you can appreciate alopecia. So alopecia total is happening to this beautiful lady there, as you can appreciate in that slide. Yeah, so that is it. I hope you're doing well on your end. And just to wrap it up is that the boundary line between self and external worlds bears no relation to reality. And the distinction between ego and world is made by spitting out part of the inside and swallowing in part of the outside. So we have to lower down our egos and do according to what we are supposed to do. So with that, have a wonderful session. I'll see you later. So kindly like, share, and subscribe as we try to make the content more easier, more understandable to us, and even to support me to reach to maybe a higher number of subscribers. So all the best in your studies and in your future endeavors. Thank you.